critical numbers and the concavity, everything that we know we're going to use. So we're going to use the first and the second derivatives. And remember, with the first derivative, a sign change will tell you increasing, decreasing, and max min. And then in the second derivative, a sign change will tell you concavity and point of inflection. So we can use, actually there's a chart on page 2, I believe it's on page 231, that I like to use. And the chart kind of has everything spelled out for you pretty well. It has the first derivative and it has the second derivative. And then you have concave up, concave down, you have increasing and you have decreasing, and then you have the signs. Okay. So you're going to have, if it's increasing and it's concave up, that's positive first derivative, positive second derivative, and it's going to look something like this. So that's concave up and increasing. If it's concave down and it's increasing, it has to look like this because you have a positive first derivative and a negative second derivative. If it's decreasing and it's concave up, it has to look like this because you have a negative first derivative and a positive second derivative. So it's concave up. If it's decreasing and concave down, it has to look like that. That's decreasing. It's also concave down. Both derivatives are negative. So I kind of like that that chart to use when you're determining all your parts of the graph sketching. Okay. So let's look at an example. And we're going to find everything on here and then we're going to graph it. So your function is 3x to the fourth minus 8x cubed plus 6x squared plus 1. Okay. And so I want to take the first derivative, and like I told you yesterday, I like to use the first derivative to find my extrema of the function. That it's easier to me than the second derivative test, but you can feel free to use either one. Okay. All right, so that's your first derivative, and I'm going to take that and set it equal to 0. And I promise I'll come back to that other homework problem, but I was running out of space, and I wanted to get to the new stuff. Okay, so there's set equal to 0, and I'm going to have 12x factored out. So factor out a 12x. Remember I told you that it's better if you can simplify as much as possible on these derivatives so that you can find where they're equal to 0. This will give us our critical numbers and our increasing, decreasing, max, min. So if I go one more step, this does factor as x minus 1 squared, or x minus 1 times x minus 1. So we have 3 critical numbers, 0, 1, well actually 2, because 1 repeats. Okay, so we really only have 0 and 1. And if we put those on the number line and put it back in the first derivative and do our test values, we've done this before, so this should be pretty painless. We put a negative 1 in there, that'd be negative, and that'd be negative. So if you multiply 3 negatives, you get a negative. If we put something in between, like a 1/2, this would be positive, this would be negative, and this would be negative. So that makes it positive. And remember, I also said that if you have a polynomial like this one is, it will alternate. So we're going to say then probably that this is negative, but we'll put a 2 in there, positive, positive, positive. Okay, so 2 would be, well, if we put a 1/2, it was negative, negative, positive. Yeah, actually at 1, okay, I lied to you. Actually at 1, if we put a 2 in, that would be positive, this would be positive, and this would be positive. So we have a positive. So we have an issue here at 1, and that's because we have a double root there. So we'll talk about that, what that does to the graph. Now we know it's increasing then. it's safer to say from 0 to 1 and then from 1 to infinity, instead of just saying 0 to infinity, because at 1 we know something strange is going on. So go ahead and write those separately. And then it's decreasing from negative infinity to 0. You have a max, or min, excuse me, at 0. Putting 0 back in the original gives us 1. And if you look, see, you go from negative to positive, so that's a minimum. So we don't have a maximum where it changes sign. Okay. All right, so let's go on to the second derivative. Okay, now we need to take the second derivative. Second derivative of the function is 36x squared minus 48x plus 12. Okay. Now, when I take this and set it equal to 0, I can take out a 12, which gives me 3x squared minus 4x plus 1. And then that does factor. I think we factored it a little bit ago, actually. 3x minus 1, x minus 1. And so we have two possible points of inflection, at 1/3 and at 1. So you can go ahead if you want to and put these critical points and the points of inflection all on one number line, or you can take the 1/3 and the 1 and put them on a separate number line. I think it's a little less confusing that way, and then you'll pick up on where it's concave up and concave down and increasing, decreasing when you get finished. So if I put a 0 in here, this would be negative and this would be negative, which means this is positive. Something in between here, say a 2/3 maybe, that's going to be positive, that's going to be negative, so that's a negative. If I put something like a 2, positive, 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 so that's positive, which means it's concave up from negative infinity to 1/3 and from 1 to infinity, and it's concave down from 1/3 to 1. So these are both points of inflection, 1/3 and 1, and we'd have to put it back in the original. 1 gives us, let's see, 3 minus 8 is -5, plus 6 is 1, plus 1 is 2. 1/3 is a little harder, so I'm going to get my handy dandy calculator and plug in the original function. Okay, so now I can go to the table and plug in the 1/3, which is already in there. It's about 1.4. So those are my points of inflection. Okay. So if you look at the putting all these points kind of on one number line, okay, the 1/3, the 1, and then the critical numbers, which were 0 and 1. So we have 0, 1/3, and 1 really. Then to the left of 0, remember it was decreasing to the left of 0. And then if we look at our concavity, to the left of 0 would include these numbers here, so it's concave up. Okay. In between 0 and 1/3, we'd have to check. Between 0 and 1/3, we're talking about numbers that are here, so it's concave up. Okay. And between 0 and 1/3, it is also increasing from our previous page. And then in between here, between 1/3 and 1, it's concave down, and it's increasing because 1/3 to 1 is concave down. And then to the right of 1, remember to the right of 1 would be this part, so it's concave up, and it's also increasing. So that's kind of using the chart that we looked at the beginning. And so now we know that it is concave down and increasing to the left of 0. Okay, concave down and increasing. What does that mean according to our chart? So, I'm sorry, it's decreasing and concave up. Let me write them up here. So minus plus means it's decreasing and it's concave up. Okay, so decreasing and concave up looks like this. This means it's increasing and concave down, concave up. So if it's increasing and concave up, it does this. Increasing and concave down. Okay, increasing and concave down. What does that look like? Something like that. That's increasing, but it's concave down. And then this one is increasing and concave up. So it would have to do like that. So it just gives you an idea kind of what the graph looks like. Okay, of course we can graph this. We know that it has a minimum. We already looked at that, a minimum at 0, 1. We know it has a point of inflection at 1/3, 1.4. Has a point of inflection at 1, 2. Okay, and we already know kind of what it does. We know it has to go reach a minimum here, and then it has to continue on like that, just like we showed here. You can plot some points, you can put it in your calculator, but you know it has to be smooth and continuous because it is a polynomial. Okay, so I have one more example on the video, and then we'll pick up, next time. I'm sure I'm going to hit the 50 minutes, so we'll have one more example, and this one is your favorite trig example. Okay, so again, we want to go through all the parts to graph sketching. So we want to take the first derivative, which would be negative sine of x plus 1/2. We're going to set that equal to 0. So that would be sine of x equals 1/2. And we're going to stick with 0 to 2 pi. So we're not having too many values. You can use your unit circle if you want to, but your x is going to be pi over 6 and 5 pi over 6. Those are the two values that lie between 0 and 2 pi, where the sine of x is equal to 1/2. Okay, so you're going to put these on the number line. Again, we're only going from 0 to 2 pi. We're going to pi over 6 and 5 pi over 6. And we're going to test our values. If you want to get decimal approximations for these, that's fine. Or you can just plug them in as pi over 6 and 5 pi over 6 values that are in between. That's fine too. Okay. I usually like to, so this is pi divided by 6 is about 0.5. So I'll put a little 0.5 here. 5 pi divided by 6 is about 2.6. And then, of course, 2 pi is about 6.3. So we put those values. That might help. And then you're going to put some value that's in between here, maybe a 0.2.